Hello everyone, I am Surendra Jain, Master Teacher in Vedantu. I have brought a series for KVPY SA stream preparation for mathematics, and in today's session I will talk about geometry. Actually, geometry is divided into 2-3 sessions, and this is our first session where I will talk about geometry in a triangle. To do questions of geometry in triangle, we need to know some basics like parallel straight lines. What are the properties of parallel straight lines? You should know what are alternate angle, what are their properties, corresponding angles, etc. I will not be talking about the theorems in detail, but we should know before doing questions based on geometry in triangles. The next one is angle sum property of a triangle. Then what are the congruent triangles and what are the criterias so that we can say that two triangles are congruent and how to use them in questions. So these are the things that you should know. Then midpoint theorem, basic proportionality theorem is very important thing to know. Okay, then coming to similar triangles, again you should know what are the criterias to say whether two triangles are similar or not. Then angle bisector theorem, Pythagoras theorem, cyclic quadrilaterals, and then these two theorems. One is angle subtended by an arc of a circle at the center is double the angle subtended by it at any point on the remaining part of the circle. So that is one very important theorem. And next is angles in the same segment of a circle are equal. See, there are many more things that I have not talked about, like centroid, orthocenter, incenter, circumcenter, excenter, and many more properties related to geometry in circles that I will be discussing in the next session or maybe upcoming sessions. So here I will be mainly focused only on these properties. So if you are not clear on any one of them, please first do a quick revision and then see what we are going to do in this session. So I have taken up some important questions, some very good questions to revise, to refresh all these concepts. So let us start with this question. Here we are given in this diagram, AB and AC are equal sides of an isosceles triangle ABC, in which equilateral triangle DEF is inscribed. Designate angle BFD by A, angle ADE by B, and angle FEC by C. Then we have to find which of the following options are correct. Okay, now to do this question, let us assume that this angle is X. Okay, then please understand, because these two angles at B and C should be same and their angle sum should be equal to 180. That means X plus, let me call this as Y, then this will also be equal to Y. So X plus 2Y has to be equal to 180 degree. So we can write this Y only in terms of X, which will be equal to 90 minus X by 2. Okay, now in other triangles we can use that angle sum property of a triangle, like in the triangle BDF. Let me write BDF. Okay, so you can see here this angle at D, because this angle is 60 degree in that equilateral triangle. Here it should be, please understand, because this is ADB, a straight line, hence this angle has to be 120 degree minus B. Why I am saying so? Because sum of these three angles, one this 160 degree and third one is B, it should be 180. So this angle has to be 120 minus B. So if I use the angle sum property in the triangle BDF, then it becomes 120 minus B plus Y, and I think here it is A, and it should be equal to 180 degree. Similarly, if I use, let me call this as equation number 1. Similarly, if we use the triangle EFC, so here once again this angle will also be 120 degree minus A, because this is an equilateral triangle. So here it is 60, this is given to us as A, so this will be 120 minus A. So in this triangle, if we use triangle BDF then triangle EFC, it will be 120 minus A plus Y plus C, and it should be equal to 180. So then this will be equation number 2. We can make one more relation if required in the triangle ADE, but let us see if this will work or not. If I equate these two equations or you can say subtract these two equations. So you can see 120 will be cancelled. Okay, or let us do one thing. Let us write left hand side 120 minus b plus y plus a is equal to 120 minus a plus y plus c. So you can see 120 gets cancelled, y also gets cancelled. Okay, so here we are getting 2a to be equal to b plus c. So the answer here should be a is equal to b plus c by 2. So what is the option? Let us see. A is equal to b plus c by 2. I think here it should have been b plus c by 2. So I think D is correct. In fact, other options can be checked. None of them will be giving you similar relation. Why I'm saying so? Because there are minus signs in B and C options. So if you do the rearrangement, then also we do not get this relation. So answer for this question is D only. Coming to question number 2, it says triangle ABC has a right angle at C. The internal bisectors of angle BAC and ABC meet BC and CA at P and Q respectively. The points M and N are the fit of perpendiculars from P and Q to AB. Then we have to find the angle MCN. To do such question, we should first make a good diagram where all the informations given can be marked, and what is asked that should also be seen clearly. So let us make a diagram like this, in which we are given that ABC is right angle at C. So this angle C is 90 degree, and if angle C is 90 degree, so angle of the sum of remaining two angles A and B will be also 90 degree. Okay, the internal bisectors of angle BAC and ABC meet BC and CA at P and Q. So this angle here, they should be equal, and they should be equal to A by 2, A by 2. Okay, similarly, this angle here will be B by 2, and here also it will be B by 2. Okay, and we are given that point M and N are the fit of perpendiculars from P and Q to AB. So this angle here is 90 degree, this angle here is also 90 degree. So the one very first thing that should come in our mind after making this diagram and doing all this analysis is that triangle ACP is congruent to triangle AMP. Why I am saying so? Let me write reason here. Because this angle CAP and angle MAP, they both are equal and equal to A by 2. One thing. Then similarly, angle at C, that is ACP, and angle at M, that is AMP, they are 90 degrees. So two angles are equal. I think this will ensure that other third angle is also equal. And also angle AMP, yeah, here AMP. And also there is a common side AP. AP is equal to AP, you can say. So that is the reason why these two triangles are congruent. And if they are congruent, that means their corresponding sides, corresponding angles, they should all be equal. So CP will be equal to PM. Also the remaining angle here, this and this, they will also be equal. Let me write these angles. I think it can be very easily seen in the triangle ACP, because C angle is 90 degree. Okay, and angle at A is A by 2. So this angle at P will be 90 degree minus A by 2. Okay, why I am saying so? Because angle at C is 90 degree. This is A by 2. So sum of remaining 2 has to be 90. So this will be 90 minus A by 2. So this will also be 90 minus A by 2. Okay, now because in that triangle, now please see in this triangle CPM, because CP is equal to PM. So this angle here and angle here, they should be equal. Let me call these angles to be x each. Okay, so these two angles will be x each, you can say, because these two sides were equal. Now in this triangle CPM only I am talking about. So the sum of two angles, let me do it here, the sum of two angles x plus x 2x and the angle at P, which will be 90 minus A by 2 2 times, 90 minus A by 2 2 times, and that will be equal to 180 degree, again by angle sum property only. So 180 gets cancelled and we are getting x to be equal to a by 2. Okay, so x is a by 2. I hope that is clear. Now similar to this I can write, I think similarly, that this y will be b by 2, or let me just quickly say, or I should again say why this b will be b by 2. Please understand that triangle BCQ will be congruent to triangle BNQ. Okay, BCQ and BNQ will be congruent because these angles are 90-90. This is b by 2, and there is a common side. Okay, and hence this angle here will be equal to this angle here, and they both will be 90 minus b by 2, 90 minus b by 2. Okay, and because these two triangles are congruent, hence this side CQ will be equal to QN. CQ will be equal to QN, and hence if this angle is y, this angle will also be y. So we can see that this 2y plus 2 times 90 minus b by 2 will be equal to 180, and this gives us that y to be equal to b by 2. Okay, now what was there in the question? They were asking that angle, what is this MCN? So this is what we need to know. Let me call this as Z. So here very easily it can be seen that angle ACB, which is actually x plus y plus z, and it is equal to 90, which is given in the question itself. So writing x as a by 2, z as b by 2, we get this z is equal to 90 minus, and I can write this as a plus b by 2. A plus b is 90, so solving this we get 45 degree. So answer for this question is 45. Okay, so this completes the solution of this question. Now coming to question number 3, it says in triangle ABC, D is a point on side BA such that BD ratio DA is equal to 1:2. E is a point on side CB so that CE ratio EB is equal to 1:4. Segment DC and AE intersect at F. Express CF ratio FT in terms of two positive relatively prime integers. One very important question, in fact very easy also, very standard problem. Let us first make a diagram of this question, what they are saying. We are given that in triangle ABC, D is a point on the side BA such that BD, DA are in ratio 1:2. So this is 1:2 here. Similarly, E is a point on CB so that CE, EB ratio is 1:4. So here it is 1, it is 4. Okay, now we have to find, and I think they intersect at this point F here. So we have to find CF ratio FD into relatively prime integers. So I am going to do one construction and that will be sufficient enough to solve this question. I will draw a line from D parallel to AE which will be meeting this side BC at M. Okay, we can redraw this diagram like this also. So here please see this DM is parallel to AE. The ratio here was 1:2 and here CE ratio EB is 1:4. Now please see in that triangles, let me mark them BDM and the triangle BAE. You can look at this thing in two ways. One is the basic proportionality theorem, because this DM is parallel to AE. So whatever ratio is there in DB ratio AD, same has to be there in BM ratio ME. So that means if this BM is X, then this EM has to be 2X. When I am saying 2X, then this is just EM, just from M to E only. Also we can see that these two triangles are similar. It could have been done this way also, that BDM and BAE are similar, because this is a parallel line. So this line BE can be considered as a transversal. Similarly BDA can also be considered as transversal. So this angle this angle will be equal, corresponding angle you can say. Similarly, this angle here will be equal to this angle here. So either by way of similar triangle or by basic proportionality theorem, it can be done. Now, so we have found this x, this 2x, but if you remember, this CE ratio EB is given as 1:4. So we have found this EB to be complete. If I write this is 3x, so CE should be 3x by 4, 1/4 of this. Okay, now we are looking for the ratio CF and FD. So once again, in the triangle CDM or triangle CFE, again by method of similarity or by basic proportionality theorem, it can be done that this triangle CDM or CFE, if you consider, these two sides are parallel. Okay, so because they are parallel, so there will be same ratio, between CE upon EM to CE upon EM, they will have same ratio as they are in CF upon FD, and that is what we are looking for. CE is 3x by 4 and FD, EM here is 2x. So if you solve it, you get this to be 3 by 8, and that is the answer. Now, similar way, we can find the ratio of AE, AF, ratio FE also. Dear all, let me tell you, this kind of questions are very important, not only for KVPY. In fact, in pre-RMO, NTSE, also you will find later on in the chapter of vectors in +2, when you will be preparing for JE Advanced, JE Mains. So in the vector also, this kind of question appears. It can be done by vector method also. But there also, this method is the most efficient one. So answer here is 3 by 8. Okay. Now coming to question number 4, it says in quadrilateral ABCD, I think A is missing here, ABCD, AB is 9, BC is 12, CD is 13 and DA is 14. Okay. Now diagonal AC length is 15, perpendiculars are drawn from B and D to that diagonal AC, meeting AC at the point P and Q respectively. Then we have to find the length PQ. So please see how we can do this question. I have two methods to do this question. Number one, let me call this PB as X and QD as Y. So let us first use the Pythagoras theorem, just Pythagoras, nothing else. Okay. So if I use Pythagoras theorem, I can write this AP square to be equal to 9 square minus X square. Okay. Similarly, in terms of X, if I try to write, I can write CP square, and this will be equal to CP square will be 12 square minus X square, and this is equation number 2. If we subtract these two, okay, if I subtract 1 from 2, so we get CP square minus AP square, and that will be equal to 12 square minus 9 square. We can use A square minus B square formula, and this CP plus AP, if we add CP plus AP, it is nothing but AC, which is given to us as 15. So this is 15, and then CP minus AP, and on the right hand side it will be 21 into 3, that is 63. Okay, so we have got a relation in which CP minus AP comes out to be 63 upon CP plus AP is AC. So we can write this as 15. So this comes out to be 21 upon 5. So this is my another equation, let us say 3. Now similar to 1 and 2, we can write now AQ square as 14 square minus Y square using Pythagoras theorem, 14 square minus Y square. And similarly, CQ square I can write as 13 square minus Y square. If I subtract them, so AQ square minus CQ square will become equal to 14 square minus 13 square. I can write this directly as 27. In this also, AQ plus CQ, you can check, this is actually AC, and then AQ minus CQ is equal to 27. So this is AC, so I can write this as 15. So we get AQ minus CQ to be equal to 27 upon 15, which is 9 upon 5. And this is my equation number 4. Now everybody listen carefully. Equation number 6, not 4, equation number 6. Now adding 3 and 6. If I add 3 and 6, you can check. I can write this as CP minus CQ. Please see how I have added them. I have added CP minus AP with AQ minus CQ. But I have written CP with CQ and AQ with AP. So if we write like this, on the right hand side it will be 30 by 5, that is 6, and it can be checked easily that CP minus CQ and also AQ minus AP both are PQ each. So 2 PQ is coming out to be 6, and hence this length of PQ is coming out to be 3. So this is one method for this question. Let us try this question by another method. Please see how. So here we are having 9, here we are having 12, and AC is 15. So if we can notice 9, 12 and 15 is a Pythagorean triplet. 9 square plus 12 square is 15 square. Okay, that means at B it should be 90 degree. At B it should be 90 degree. Okay, so if I take this as some angle, let us say I took this as X, this as Y, let me take this angle as say alpha. Okay, then this angle at B will become 90 minus alpha, because this angle is 90 here, and also because angle at B is 90, angle at B is also 90, so this will also be 90 minus alpha. Okay, so you can see the triangle ABP is similar to triangle ACB. It can be checked. ABP and ACB, they are similar triangle. So if they are similar triangle and I take the ratio of corresponding sides, it can be seen that AP upon 9, AP is opposite to 90 minus alpha and 9 is opposite to 90 degree. So this will be equal to opposite to 90 minus alpha on the right hand side will be 9, and upon opposite to 90 it is AC, that is 15. So we get AP to be equal to 27 upon 5. So we have found the length AP, that is coming out to be 27 by 5. So if we can find AQ also, then we are done. Okay, now to do this question, please listen carefully. How can this be done? Please see. If I drop perpendicular from C, okay, and let us call this length as A, and because AD is 14, so this will become 14 minus A. Okay, so once again using Pythagoras theorem, and let us say this height is h. So this square of this height h square can be written in two ways. One is AC square, that is 15 square minus 14 minus A, and in that other triangle it can be written as CD square. CD is how much? CD is I think 13, yeah. So this will be 13 square minus A square. So we can now solve this, and we will be able to get this as 15 square minus 13 square is equal to, it will become 14 minus A whole square minus A square. So here it becomes 15 plus 13, 28 into 256 is equal to 14 square minus 28A. A square will get cancelled. So from this I think we get A square to be 28 can be cancelled. So that will be how much? 7 minus 2. So A comes out to be 5. So please check. A is equal to 5. And if A is 5, H will be equal to 12. A is 5, H is 12. And 14 minus A will be equal to 9. Okay, so 14 minus A will be equal to 9. Okay, now you can see, suppose if this point is M, this is 9 here, H is 12 here, and AC is 15. So can we say that triangle ABC is congruent to triangle AMC? This method was possible only if we could see that these two triangles are going to become congruent triangle. Otherwise, if it was not so, this method would not have been possible. So if they are congruent, so these two angles like angle BAC and BAC and angle MAC, they both will be equal to alpha. So if this is alpha and this is 90 degree, okay, I think this will again become 90 minus alpha. So I hope you understand that triangle ABP will be similar to triangle ADQ. Okay, and in these two triangle, the ratio of their similarity, because ABP, ADQ, they are similar. ADQ, not APQ, it was ADQ, yeah, ADQ. So ratio of similarity is nothing but 9 upon 14, because the corresponding side of this smaller triangle is 9 and here it is 14. Okay, so I think I can find now AQ also directly by saying it will be 14 upon 9, because AQ is the corresponding side of the bigger triangle. So it will be 14 upon 9 times the AP, which we have found already using similarity. It was 27 by 5. So if I put 27 by 5 here, so AQ, this will be 14 by 9 into 27 by 5. So how much will it be? 3 times here. So it becomes 42 upon 5. 42 upon 5. So this is AP, this is AQ. Let me call this as equation number 2 and let me find PQ here. So PQ will be AQ minus AP, and that comes out to be 42 minus 27 is 15, 15 by 5, so 3. So you can see this way also we can prove that this comes out to be 3. Okay, now coming to the next question, it is question number 5, says triangle AEF is a right triangle with AE is equal to 4 and EF to be equal to 3. And because it is 90, so I think this becomes equal to 5. Now the triangle is inscribed inside a square ABCD as shown. So we have to find the area of the square. Now please see how this can be done. If I call this angle to be alpha, because this is 90, this will be 90 minus alpha. Okay, this is 90 and BEC is a complete straight line. So this remaining angle here will also be alpha. So this is alpha, this is 90, so this will also be 90 minus alpha. So I think we have found two similar triangles. What are those? I think triangle ABE is similar to triangle, it will be ECF. So these two triangles are similar triangle. Okay, and in these triangles you can see that side opposite to 90. So the ratio of similarity, I am writing the length of corresponding sides which are opposite to 90 in both the triangles. So you can see opposite to B it is 4 in the triangle ABE, and the other triangle opposite to C it is 3. So the ratio is 4 upon 3. So this bigger triangle and this smaller triangle, their corresponding sides will be having a ratio of their sides as 4:3. So let me take AB as 4A. AB as 4A, that is the side of this square. So then I think I can say that side EC will be equal to 3A, isn't it? Because this EC is opposite to 90 minus alpha, and here 4A was also opposite to 90 minus alpha. But because this BC is the side of square, so I think I can say that BE will be equal to A. So this length of BE can be written as A, because this BC is complete equal to BA, that is equal to 4. So using Pythagoras theorem, we can write, using Pythagoras theorem, we can write this 4A whole square plus A square, and this will be equal to 4 square, that is 16. So we get from this 16 plus 1, 17A square to be equal to 16. And that required area here has to be equal to 4A whole square. 4A whole square, which means 16A square. and we have found a square to be 16 upon 17. So that is the answer. So answer will be 256 upon 17. So that completes the solution of this question. Okay. Now coming to the next question, that is question number 6. It says let ABC be an acute angle triangle. Let D comma F be the midpoints of BC, AB respectively. Let the perpendicular from F to AC and perpendicular from B to BC meet at N. Prove that ND is equal to circumradius of triangle ABC. I think here should be triangle ABC. Now once again we should make one proper diagram to understand what exactly is given and what exactly is asked. So please see what they have given, that ABC is acute angle triangle and D and F are the midpoints of BC and AB respectively. Perpendicular from F to AC is drawn, okay, and perpendicular from B to BC. So from B to BC means there is a line which will be passing through B and it should be perpendicular to BC this way, and they meet at N. You can see this perpendicular from F to AC has to be produced backwards, so that the perpendicular at BC passing through B should meet this perpendicular from F to AC. So this is how N point will be constructed. Now we have to prove that this ND length is equal to the circumradius of this triangle ABC. Okay, so this is what this question is, but to do this question, I think we have to do some construction here. One of the method can be that you can use some, you can do some construction, and then we will be able to find this, this whatever it is required. Now please see, I am taking center of the circumcircle of this triangle ABC. I am assuming that O is circumcenter. Circumcenter means center of that circle that passes through all three vertices ABC. So as you know, center joining the midpoint of any chord has to be perpendicular. Please understand, this O is the center. O is the center of that circle that will be passing through A, B and C. So you can see that like this, if we draw, BC is a chord and AB is also a chord. Because D is the midpoint of this chord, so if you join O to D, it will be 90 degree, and similarly if you join O to F, then it will also be 90 degree. Okay, now I have joined B with O and A with O. So please understand, because this angle is C, so angle subtended by AB at O will be equal to 2C. And because center is joined to midpoint, so these two angles both should be C and C only. This can be clearly seen here. Okay, one more thing. Because this angle is 90 we are given, this angle is also 90 here we are given. Okay, so in that quadrilateral N, and let me call this as M here, NMCB. NMCB, you can check, this angle is 90 degree, this angle is 90 degree. So this is cyclic. As these two angles, let me call this as X, this as Y, as X plus Y is 180. In fact, because they are 180, for this circle, NC has to be the diameter. Okay, now, because this is cyclic, so I can say this angle here, MNB will be equal to 180 degree minus C, because their sum should also be now 180. Now one very important thing that can be observed from here, let me write this angle as 180 minus C, and you can see now that quadrilateral FNB and O. Let me check. FNBO. Yes. So the sum of two opposite sides, you can see sum of two opposite angles is again becoming 180. Is cyclic once again. Okay. Because this angle FNB, let me write it here, angle FNB plus angle FOB is 180. Okay, so there will be a circle that will be passing through FNBO. Okay, let me go to the another diagram which after doing all the calculation, I think I can write these values here. I think we proved that that quadrilateral FNBO, let me write it here once again, FNBO is cyclic. Okay, and you can see in this triangle, in this quadrilateral, this angle at F, that is BFO, is 90 degree. Angle BFO is 90 degree. So if I join O with N, if I join O with N here, because this F and BO is cyclic, so this OB will have to make same angle at F as well as at N. So this is cyclic and this angle BFO is 90. So this angle BNO will also be equal to 90 degree. Now please listen carefully. In that quadrilateral NBDO, I hope you can see this angle is 90 as it is given in the question. This is 90 because center is joined to the midpoint of the chord. This we have proved that it is 90. Hence, the remaining angle will also be 90 only. So this quadrilateral NBDO is rectangle, isn't it? And as we know, for a rectangle, its diagonals should be equal. And what are the diagonals? One diagonal is ND and other diagonal is OB. Can you see it? One diagonal is ND, other diagonal is OB, and hence this is equal to the circumradius. You can very easily see OB is nothing but the circumradius. Okay, so this is how we have proved this thing what they have asked. So this completes the solution of this question also. Now everybody, let me tell you the KVPY schedule. We have started this series from 29th of May and you can see all the subjects, physics, chemistry, maths, bio sessions there for essay as well as for SX. Timings are mentioned in the screen. You can go through it. Dear all, you can see Vedantu Eklavy on the screen. It is one very important thing in the domain of online for JEE Advanced preparation. So if you are preparing for JEE Advanced or you are planning to prepare for JEE Advanced this year or next year or next to next year, then you must explore what Vedantu Eklavy is. If you already know it better, otherwise just Google it, you'll come to know. I am sharing with you some useful links related to our batches going on in Vedantu. So this is the link to a notice board and this QR code will also take you to the same place where you will find the notification regarding new batches coming up or new things going on in these batches. So just follow this notice board. It can be useful thing for you. Those students who are writing JEE Advanced this year in 2022, this is the link and this is a QR code to join the Telegram channel where we are putting all the important information how you can join these batches of Eklavya. So do join that channel. It will be a useful thing for you. Similarly, 2023 aspirants, 2024 aspirants, this is again a link for the corresponding Telegram channels. We have created one channel with the name V Impact where you will find the solutions of previous year papers like JEE Advanced and KVPY, and we are increasing the papers as time passes. As of now, you will find for JEE Advanced 18, 19, 20, 21 year, and for KVPY it is 18, 19 and 20. All these solutions are question wise. You will find one video for one question. We have tried to give you alternate solutions. So it will be a good, you will find very good solutions of all these questions. So please explore that. Now coming to the teaser question. So what is the teaser question for this session? It is in a triangle ABC. You are given that BDCE are internal angle bisectors and angle CED is 18 degree and angle BDE is 24 degree. Then you have to find the angles of triangle ABC. So that is the teaser question for today's session. And if you find the solution, if you solve this question, do send this solution to this email ID eklavyasupport@vedantu.com with the subject line of this mail as teaser question, and here you will write maths. Okay, we will check your solution, and if we find it, if we like this solution, then we will contact you and we will try to make you part of our upcoming batches or maybe ongoing batches also if it suits you. Okay, so that is all for today. Thank you so much, everybody. Bye, and I'll be coming with next session on geometry only. So stay tuned.